Hi guys, sorry again, I just found out reviewing the video that when I used Google Doc, it didn't come up on the screen. So let me explain to you about oxidation states, all right? As I said, I got from Singapore, this guy. Now the thing didn't come out from the time 3 minutes 25 to 22 minutes 51. I repeat again. So from 3 minutes 25 to 22 minutes 51, I'm going to explain to you using this this part here, which didn't come up in the video, okay, of part 5, okay? So as I said, I'm going to talk about the oxidation state, right, which is the one which is not in the video. So I'm going to say it again now. Sorry about that. Okay, now to understand oxidation state, we must understand that there are two kinds of compounds, okay? Like here it says ionic compound. I'm going to put the, let me see. Okay, so I was in the topsy-turvy. I just, whoa, why, how come it didn't come out? See, there are two kinds of compounds. First, of course, here, ionic compounds, and of course, covalent compounds. For ionic compounds, it's quite simple, right? Ionic compounds are formed from metals and non-metals, right? Metals are group 1 here, group 1, group 2, and transition metals, okay? When they combine with non-metals, group 5, 6, and 7, okay, they form ionic compounds. So group 1, group 2, and group 3 metals and TM metals, they lose electrons, so they become positively charged, okay? Here is positively charged. And group 5, 6, and 7, when they accept electrons, they become negative charged, okay? Like here. And 3 minus, nitrite, O2 minus, oxides, Cl minus, which is your chlorides, okay? So quite simple. The charge here becomes the oxidation state, like sodium Na plus, right? Na plus here, this becomes the oxidation state. Cl minus becomes the oxidation state. It's quite clear. But actually, nothing is 100% ionic, another percent, nothing is 100% covalent. Okay, but now mind. So ionic compounds is quite easy to spot the oxygen state. Now for covalent compounds, it is a different ball game. Now of course here I give you here is magnesium nitride. Okay, this magnesium, by the way, is form 5 nitride, De. Okay, so nitride. Okay, so it's N minus 3, right? So it should be 3 minus that. Sorry, 3 minus. It should be 2 positive. Okay, on top here the number is first, then comes the sign. Number is first, then the sign. Okay, now, okay, like here. Okay, now if it is a covalent compound, like here, water. Okay, so you can see that oxygen here has got 6 electrons, right? So it shared 2 of it with the hydrogen. Okay, so oxygen, because it's more electronegative than hydrogen. I can see down here, I've got, I think, yeah, here. Okay, so this is the on electronegativity, okay? Oxygen is 3.44 and hydrogen is 2.2. So oxygen being more electronegative, right? So like here, now this water, isn't it? So being more electronegative, it acts as if it owns the 2 electrons from hydrogen, 1 here and 1 here. So it's become negative 2. Okay? Hydrogen acts as if it's lost the electron. It's become positive. Okay? Positive. Right? Now, oxygen, in this example here, F2O, okay? Fluorine. Now, you can see oxygen here. All right? 1, 2, 3, 4, 5, 5, and 6. So now this is your fluorine one. So fluorine again act as if it's because fluorine is the most electronegative substance in the world. 3.98. Oxygen is 3.44. So it will act as if it has taken this electron from oxygen. So it's like minus 1. Here, this fluorine take the other one. So oxygen has lost 2 electrons, so it's plus 2. So with fluorine, oxygen is plus 2. So oxygen can be minus 2 or plus 2. Okay. Now, of course, when it comes to, if you talk about peroxides, like H2O2, the H2O2 here, right? So this is a peroxide cross and dots. Oxygen here, 1, 2, 3, 4, 5, 6. Okay, so 1 here. Now here is a covalent bond. Okay, 6 here. Right? Because these two bonds here, because they are same electronegativity, so they don't consider lost or gain. So here, oxygen here gain this electron from hydrogen. This is -1, and hydrogen is +1. Here, X is gain. Gain the electron here, so it's -1, and it's +1. Okay, so for peroxide, oxygen is -1. So oxygen can be -2, -1, and +2, and of course 0 if it's an element. Okay, now you can see down here. All right, this guy is from Singapore. I got his notes here. Okay, so you can see here oxygen. Okay, oxygen here, right? -2, right? If it's bonded to fluorine, right? Is +2. Where is it? Okay, because fluorine is more electronegative. Okay, so for peroxides, is -1. So remember, oxygen can be 0, -2, which is common one, +2, and what? -1. Okay, fluorine, right? Fluorine is always -1 because it's the most electronegative. Cannot, right? So that's what I missed inside there. Okay, so metals are normally positive. Now hydrogen, okay, hydrogen here, hydrogen. All right, hydrogen. Remember, if it's element, it will be 0. But if it combines with a non-metal, right, like HCl, because here is a covalent substance here. See, it didn't come out in the video because I don't know what happened. Okay, covalent. So chlorine is more electronegative than the hydrogen, so it gains its electron. So it's -1. Hydrogen is +1. Okay, quite simple, isn't it? Now, if hydrogen combines a metal. All right, here I said combines with metal, okay, metal here, right? So metal plus hydrogen, okay? For example, sodium, okay? Now this is your NaH. This is sodium hydride, by the way, sodium hydride. So, now it's an ionic substance. So sodium is less electronegative than hydrogen. You can see from here. All right, sodium. Okay, sodium is 9. Sorry, sodium is 0.93. Hydrogen is 2.20. So hydrogen is more electronegative than your sodium. So that's why hydrogen, sodium hydride is H is negative. Okay, so it's an ionic compound. So H is negative here, and sodium is positive. Same thing with magnesium. This is a magnesium, okay, 2 positive, okay, hydride, okay. This is called magnesium hydride, okay, magnesium. Form 5, they ask you for the cross and dot, hydride. Okay, hydride. So same thing here, positive here, and here's negative. So, right? So now the other one, of course, is the sum of the oxygen state here. So which I work it out, which didn't come out in the video. Too bad I do this again. Sum of the oxygen states, right? This is called sum. Okay, oxygen numbers. Now, for example, this one here. This is a potassium chromate. Okay, potassium chromate K. See, I do it again, Cr2O7. Okay, now if it's a compound, the whole thing here is charge 0. Okay, now there are 3 substrate elements here: potassium, chromium, and oxygen. Okay, so potassium is +1 for sure. Oxygen is 2 negative for sure. So let's say chromium here is X. So 2 times +1 plus, see, sum of, is it? 2 here, times X. Okay, X plus positive negative doesn't matter, it will come out 1. plus 7 times minus 2 is equal to 0. Why? Overall charge of a substance is 0, isn't it? So it's plus 2 plus 2x minus 14 equal to 0. So 2x minus 12 is equal to 0. X is equal to plus 6 here. So chromium is plus 6. So it's how you can find out the oxidation state by this method, okay, summation. MnO4 minus, it comes from potassium manganate, okay? Right, so this is plus 1, so this whole thing will be minus 1. See now, so you can see here, let's say it's A here, so it's 1 times A times 1 here, plus 4, remember the whole thing here is minus 1, so oxygen is minus 2. So 4 times minus 2 is equals to minus 1, right now? Okay, so A minus 8 equals to minus 1, so A is equals to what? Plus 7, that's why Mn here is plus 7. Okay, so this summation, this is done in form 5. The last thing here, which I'm going to talk about here, is for carbon compounds. Okay, like for example here, all right, here, this one here. The carbon for each of them are different, no? Because carbon here to hydrogen, hydrogen, hydrogen here. Okay, carbon is more electronegative than hydrogen. You can see from here. Carbon, okay, carbon is 2.55. Hydrogen is 2.20. About the same, but it's a bit more. That's why in your alkane, you say they're about the same. So there's no charge. It's not polar, so it's unreactive for alkanes. So carbon is negative, okay, from here. So, but how do you find out all the charge? Very simple. So this plus, this one is plus 1, plus 1, plus 1, plus 1. So the whole thing is 0, so it's minus 4. Now, for CH, all right, and let's say this is H and F here. Now this is plus 1, plus 1, plus 1, this is minus 1. So overall is 0, so this is minus 2. See now, so this carbon is plus minus 4, this carbon is minus 2. See now, and then of course the next one here is C, H, H, F, and F here. This minus 1, fluorine is always negative, plus 1, this is 0. See now. Okay, for the last one, right, if it's CF4, okay, it's minus 1, minus 1, minus 1, minus 1, and this is actually plus 4. Okay, so you can see they are different for different compounds for organic substances. Now for this one here, this carbon here, right, because it's same here, same, so now this whole part here, right, this whole part here, right, is equal to 0. So hydrogen is plus 1, plus 1, plus 1 is minus 2. So there are 3 positive, 1 negative, so this carbon is minus 1. So it's minus 1 here. See now. So now this whole part here, okay, this whole part here, so it's plus 1, minus 2, plus 1. So this will be 0. See, carbon here is 0. Okay. Now this whole part here also equal to 0 here. Okay. So it's plus 1, plus 1, plus 1. This will be minus 3. Minus 3 here. Right? So now individually, this is minus 1. The first carbon is minus 1. The second carbon is 0. The third carbon is minus 3. Total is minus 4. So average 3 carbons over 3. Now this is the average valency for, see here, for carbon. Okay? Review it again and see what I'm trying to say. Now all this you can look over yourself, okay? So this is the part where I missed out. Okay? So if you see this again, you can tumble back. So remember for the other one, it starts with 22 minutes 51 seconds. Okay? That's where I continue for this part here. Okay? Okay, sorry, bye-bye. Thank you for watching.